Okay, so this is our first video lesson for level 1. This comes from chapter 1, section 3. It is intended that as you take notes for this video that you may have your book with you open to chapter 1, section 3, and you can see other things in there or definitions that might go along with things that we say. Some of the vocabulary that we're going to be talking about today: point, space, line, collinear, plane, and coplanar. I'm going to start off with a brief explanation of those, and you can end up writing down whatever you need. Some of these, like point, is an undefined term. A point just represents a location, a point in space, a point on your piece of paper, on the ceiling, anywhere. Space is just the set of all points. So all the points that exist, put them all together, you've got yourself a space. These two terms are generally considered undefined terms. Line. Now a line is a set of all points extending in two opposite directions. There are infinite points on a line, and we're going to talk a little bit more about how to name a line and lines in a second, but the definition was a set of points that extend in two opposite directions. Collinear would be if we wanted to talk about a finite set of points, maybe 5 or 6 points or 3, and say, are they on the same line? So if I was to draw a few dots on the board, those 4 points ended up being collinear. But if I draw three points like this, those 3 points are not collinear. We cannot draw one line that goes through those 3 points. Next up is plane. Now, a plane is a flat two-dimensional surface that extends in all directions forever. This whiteboard is a great example of a plane if you imagine it going on forever, up, down, and left and right. Any flat two-dimensional surface can be considered a plane. Coplanar now refers to things that lie on one plane, but we have points and we have lines. If a point and a line are lying on the same plane, they are coplanar. You can have a set of points coplanar, a set of lines, or a combination of the two. Let's start off talking about lines. Lines mean the set of all points that extend in two opposite directions. Lines can be named in 2 ways for this class. One is to call this line AB. Notice the arrows above the AB. This is to say that it extends forever. Or we could call it line T. T is a lowercase letter at one of the arrows on the line. Should we name it with the points, which is the most common method, we only need 2 points. We never name a line with 3 points. You only need 2, and we'll come to that again later. So, lines, 2 points to name it. Make sure you put the line symbol above. Here's a line, and the question to think about right now is, what are the possible ways that you could name this line? How many ways could you name it? So, the answer to this is there are 6 different ways to name this line. We could start off one by saying RS, and one is ST. But it gets a little interesting when we say that we could also name it SR. Which leads me to another question. What is the difference between naming the line RS and line SR? Think about those 3 answers for a second. The correct answer here is C. There is no difference. If you go through S and R and extend forever, you will contain the same points as if you said it backwards. So, there is no difference between line RS and line SR. Planes can also be named in 2 ways. If you don't have a designated point, we could just call it plane P with a capital letter up in one of the corners. But generally speaking, we name a plane with 3 letters. Plane ABC. The most important fact is that those letters those points have to be non-collinear. They cannot be 3 points that are in a straight line. I have a visual to show why. Try to answer this question and we'll start to understand. How many planes do the points S, A, and T lie on? So as we look at this picture, seeing one plane here and another plane going through here, how many planes do the points S, A, and T lie on? Generally, the first answer I get is the people that say 2. They see the red plane, the gray plane. The correct answer, however, is D, infinite planes. There could be another plane represented by this sheet of paper that goes in and hits S, A, and T like this. There are infinite different planes that could go through a line. So therefore, we cannot name a plane with 3 points that are collinear. The red plane would be better named SRT, and the gray plane would be better named SWT. So, a question that you need to think about for our upcoming test is the explanation. Why must a plane be named with 3 non-collinear points? And this is because 3 collinear points would lie on infinite planes and no one would know what you're talking about. Every point on line TS is on both planes. Therefore, collinear points do not define a plane. All right, let's go ahead and move here. Now we have a 3-dimensional figure as we see this cube. And a couple of examples. Point A, B, F, and E are coplanar. A, B, F, and E. Many of us see this as the front of the box. A, B, F, and H are not coplanar. Well, A, B, and F, those 3 alone form a triangle and they make the front of the box. Well, you throw H on there and now we're not coplanar. That's a 3-dimensional shape. Those 4 points are not coplanar. It's not H that is not coplanar, because we could look at B, F, and H and see that diagonal plane running through the cube and think, well, B, F, and H are definitely coplanar with D, and A is the one that's not coplanar. So it's not that one point is not coplanar, it's that the group of 4 together are not coplanar. Lastly, D, B, G. A lot of students think that those are not coplanar to start. D and B are down on the floor, G is up on the ceiling in a different corner. However, these are 3 points and they're not collinear. They form a triangle. That triangle is definitely a plane. If we try to draw this on here, we can go from here to G, and you've got yourself essentially a ramp. It's as if you put a roll of wrapping paper from D to B. Could you roll it so that some part of that paper then hits G with a nice flat ramp? Yes. D, B, and G are definitely coplanar because any 3 points are coplanar. Why is this, that any 3 points are always coplanar? Well, there are only 2 options. 3 points are either collinear or they're not. If they're collinear, we had just learned that they lie on infinite planes. They lie on the whiteboard and they lie on the plane that goes through it this way or this way. So they're definitely coplanar. The other option is that they're not collinear. Well, if 3 points are not collinear, they form a triangle. A triangle is a 2-dimensional figure and therefore coplanar. So if I ask you, 3 points are coplanar? The answer is always. 4 points coplanar? Sometimes. Sometimes they are. Sometimes they're not. Okay, the next thing we're going to talk about is postulates, and we're almost done here. A postulate is a basic accepted statement of fact. We do not have to prove these things. They are accepted facts. Let's take a look at what some of these basic postulates are. 1. Through any 2 points there is exactly one line. I think of connect the dots. If I had a connect the dot picture with a 1 and a 2, there is only one straight line that I can connect 1 and 2 with. This is why we only need 2 points to name a line, because through any 2 points, there is only one line. It becomes unique. Second, if 2 lines happen to intersect, then they intersect at exactly 1 point. This does not say all lines intersect. It says if they do, they will never come back and hit each other again. Number 3, if 2 planes intersect, so if the planes come together, they will always form a line. Try to think of when 2 walls come together in a room, they form the corner of the room. That corner is a line. As the ceiling is met by the front wall, they form a line. When planes intersect, they form lines. Plane RST, the red, plane STW, the gray, intersect at line ST. The final postulate is through any 3 non-collinear points, there is exactly 1 plane. 3 collinear points, we don't know how many planes there are, it's infinite. But if you have 3 non-collinear points that form a triangle, there is one and only one flat surface that will touch all 3 of those points. So it takes 3 non-collinear points to make a plane. I like to think of it as a triangle, flat 2-dimensional surface. This is a post-lesson quiz that you can look at. You can pause the video now if you want to see these for longer, and you can try to answer these questions. Most likely we will go over these questions in class as a warm-up one day after we have studied this lesson. That's it for Chapter 1, Section 3. Hopefully you took some good notes.